Okay, question number 13. It's going to be SOHCAHTOA and Pythagoras maybe, because this pyramid will be chocker with right angled triangles. Let's just confirm this. It's got a square base, so it's got right angles in the corners. It is directly above the center of the base. I've been given some names for some of the dimensions, so that is 2x, so it's got to be x and x when you split that in half. The height's h. And these sloping journeys from corners to the top are 5. So, this looks like it could come from Pythagoras. That's my dirty clothes from the week. That's on the tape. Okay, so I've got to find something to do Pythagoras on. It's got to be something that mentions h. It's only got 2 marks, so it can't be that hard. Well, maybe this is the slow way, but I'm going to call that w. I've got a red triangle, which is right angled, and I've got a blue triangle, that's right angled. So from the blue triangle we have a fact: w squared plus w squared equals 2x all squared. So 2w squared equals 4x squared, so w squared equals 2x squared. On the other hand, from the red triangle, we have h squared plus w squared equals 5 squared. But we know that w squared is 2x squared. So there we go, 2x squared equals 25 minus h squared. So that's Roman numeral part 1. Now, the volume of a pyramid is 1/3 of the area of the base times the height. So what is the area of the base? It's 2x times 2x times the height. So that's 1/3 times 4x squared times the height. Now that this thing we're asked to find has no x's in it, but it does have h's in it, so let's get rid of this. If you double everything there, you get 4x squared equals 50 minus 2h squared. So it's 1/3 times 50 minus 2h squared times h again. Multiply that out, you get 50h minus 2h cubed all over 3, which is what we're asked to show. Okay, so find the value of h which it is a stationary value. Okay, well that's derivative. Let's get this ready for calculus first. Differentiate that, you get 50 over 3 minus 2h squared. You want to know where it's stationary? It's where the derivative is 0. So 0 equals 50 minus 6h squared, so 6h squared equals 50. H squared equals 50 over 6. Equals 25 over 3, so therefore h equals plus or minus the square root of 25, which is 5 over the square root of 3. So in other words, h equals 5 over 3 because you can't have a negative height. So that's the value of h, for which there's a stationary value. Now prove it's a maximum. One way to do this is to press on to a second derivative. Which is negative for all positive h, which is all the relevant h. so therefore maximum. Or you can do a derivative table where you end up drawing this business physically. But anyway, that method is good for that. And calculate the angle between the edge AE and the base when h takes this value. Part 5. Calculate the angle between the edge AE and the base when h takes this value. So it's back in the red triangle. So the red triangle has a 5 there and a root 5/3 there. That's the angle. So sine theta equals root 5/3 all over 5. So go shift sine, type that using fraction button on a nice modern calculator, and out pops 35.3. Okay, so question number 14. Got this diagram of a speed hump. So what's the... So that, with the 5 underneath, is this. So that and that differ only by the fact that this doesn't have the division by 5. So that'll be 5 times as high. The maximum height of that is 0.25. The maximum height of that will be 1.25. Wait on. Oh, sorry, I misread that. That's 0.2. So therefore it'll be 1, which is 5 times 0.2. So therefore the maximum height of the speed hump will be 0.2 meters. It's a bit strange that I've got the word hence there. I'll do it the other way around. The way I worked out the maximum value of that was by looking at the maximum value of that, not the other way around. It says you can't, the marker can't give you 1 if you use the graph, but how would they know if you use the graph? Anyway, I'll talk about it the other way. That's a power of 4. Powers of 4 are positive, so you can't get this to be negative. If you're subtracting something from something and you want to keep it high, make the subtraction as low as possible. We just established it can't be negative. So if you want to make the thing you're subtracting as low as possible, make it 0. You can make it 0 just by x being 1, so therefore the maximum height is 1. This just comes from doing the binomial expansion on that. First let's do the binomial expansion on this. So whatever that number is tells you how many pluses to write down. Open up those spaces between the pluses with the C's. Write that number on top of all the C's. Underneath the C's, count down or count up from 4 to 0 or 0 to 4. And now do falling powers on the first term and rising powers on the second term. Simplify these. The first and the last are always a 1. The second and second last are always whatever the power was. That comes off a calculator, that'll be 6. Now just tidy. Even powers of a negative are positive. Odd powers are negative. That'll be x to the power of 4. That'll be x cubed. The x squared, that'll be x cubed, and that'll be x to the power of 4. So fully tidy, it's this. Oh, sorry, that's not right. So therefore, y is 1 minus that all over 5, which is a fifth that minus that'll be blank, and everything else will be changed from negative to positive when you multiply by this -1 there. So it'll be 4x minus 6 squared plus 4x cubed plus x to the power of, minus x to the power of 4. And that's what it's asked to show. Find the area of the cross section. Well, this is now ready for calculus. So here it is here. Done a bit of mathsmosis there, the fifth comes out. On the terminals we write the left and right extremities of the area. Second stage, move them over to the right of a square bracket. Inside the square bracket goes the primitive. So a fifth times write this twice, once with a 2, once with a 0 where everything is. If there's a 0 being powered up and subtracted, that'll be 0. But this takes some work. Pump that through a calculator and you get 0.32. Better express it in units. This is square meters. So that's 14.